So I will try to do mostly demos around the Internet of Things. So how about maybe a quick intro on what is the Internet of Things? I think you guys kind of start to know what is the Internet of Things, but just to remind you of a few nice use cases you can think of when all the things around you start being able to talk to each other. Smart grid, the ability for the utility company who is producing electricity to actually optimize the production of electricity depending on the consumption in the households, right? You have smart power meters in every house, and then you can start collecting all the information about the consumption and start producing electricity in an optimal way. You might or might not know that it's actually quite difficult to store electricity, so you need to produce the electricity at the very same moment it's being consumed. So yeah, smart grid is kind of a nice use case for the Internet of Things. Everything related to transportation, and if you think about like UPS or FedEx being able to deliver a parcel, not necessarily at your house, but depending on where you physically are, right? If FedEx knows that maybe on someday you're in a different location, there might be ways to optimize the delivery of the parcel. eCall, what is called emergency call in Europe, it's now becoming mandatory in cars to be able, when there is an accident, to automatically send your GPS position to 911 or whatever is the emergency service in your country. Healthcare, everything related to healthcare, the ability to connect a pill holder to the internet to know if someone who's got Alzheimer's disease, for example, actually took their pills or didn't. So there are several use cases, right, for the Internet of Things. We keep getting and seeing more and more objects being connected. What people often don't mention is that we will need there will need to be developers building those solutions, right? So there's lots of Java developers out there, and at Eclipse IoT we're trying to help by providing open source projects that help building IoT solutions. Many of them are targeting Java developers, but of course when we talk IoT we also talk embedded software, so C, C++ is also quite popular in the IoT space. And well, there are lots of technologies being used. We focus the effort around two main aspects. Implementation of standards. If you want to build an interoperable Internet of Things, you need open protocols, you need open APIs. So we provide implementations of such protocols, for example, and application frameworks and verticals for like home automation or industrial monitoring, that kind of stuff. So yeah, I'm going to talk about several Java projects today. Not necessarily because Java is the best fit for IoT, it's just that there's like a huge ecosystem of libraries out there, a huge ecosystem of developers. The tooling is quite good, like if you want to do remote debugging and stuff, well, you can use Eclipse, for example, and even on the embedded space, actually, you can also run Java. But I'm going to mention also some projects that are not Java. So very quickly, typical end-to-end IoT scenarios, you have things, right? They might be able to sort of directly get internet connectivity because, or at least access the network directly. They have a Wi-Fi chip, they have a cellular modem embedded right in the device, so you will probably be able to have some embedded software running directly in the pacemaker or in the smart pill holder that will be directly communicating to the cloud or to other devices. Or what you often see is that, especially when you want to sort of retrofit existing devices, you're going to use a so-called gateway to talk to the existing device over serial protocol, that kind of stuff, and then provide the connectivity. So in the case of gateway, the intelligence is probably going to be developed on the gateway, whereas when you have direct networking support, you might be able to program the device immediately. But the idea is that you want to be able to communicate, you want to reach the cloud, sort of, be able to start sending data, information to a backend server. You might want to use the server to implement one-to-one or one-to-many communication scenarios between the devices, right? If they don't live on the same physical network, you'll probably use some kind of broker to implement the communication. And at the other end of the spectrum, you will want to build web applications, mobile applications that use the data. You may want also maybe to feed the IoT data into a backend infrastructure. Do you want to do big data, data analytics, whatever. So at the gateway level, what are we talking about? Well, a gateway, if you're sort of prototyping the IoT, would be a Raspberry Pi, right? That's typically a gateway. It's smart enough for running possibly complex software stack. The gateway is going to be in charge of bridging possibly lots of sensors to the internet, so you want to have enough memory to do local data consolidation. If the network is down, you will be doing some caching as well. And of course, well, you have network capabilities, so on the Raspberry Pi there would be Ethernet, that would be using a Wi-Fi dongle, 3G dongle for getting internet connectivity. In more industrial scenarios, that would be the typical kind of hardware. It's ruggedized, can go in a very humid or very hot environment, and it probably has way more connectors and way more communication capabilities than the Raspberry Pi. You can talk CAN bus, Modbus, that kind of stuff. So, for what's going to be the role of the gateway? Connecting the devices, the things to the internet, and you're going to need also to manage all this hardware, the gateway itself, the sensors, the actuators on the field, your thermostat, etc. You need to connect and manage. So for connecting, there are two popular IoT protocols. One is CoAP, one is MQTT. So without going into much detail, you can think of CoAP as HTTP over UDP. So that is a binary protocol for doing REST-like interfaces. So instead of, if you do HTTP, it's quite verbose, right? You have all these HTTP headers, which is basically text. It takes lots of bandwidth on your communication channel, so CoAP is taking the same approach. Same kind of headers, you can do caching, you can do proxying, etc. Only this is going to be binary. So we have open source implementations of CoAP, I'm going to talk about it in just a minute. And then there's MQTT, which is more implementing a publish-subscribe kind of communication scenario, and it's on top of TCP. Although there are some ways to read over UDP as well. So CoAP, well, it's basically for building the web of things. Especially if you think IPv6, the ideal Internet of Things, every device is going to have an IP address anyways. So all the devices could actually be servers, mini HTTP servers, if you will. So they all run a small CoAP server, and you can query them. You can get the slash green resource on the light bulb, and it's going to give you an information. You want to start the car, well, maybe you just post a CoAP packet on the engine slash status resource. So CoAP and Eclipse, so for Java developers, it's in the Eclipse Californian project. So it provides basically all the APIs for building CoAP clients and servers. It includes the SSL stack, if you will. So in CoAP, it's called, for UDP, it's DTLS. It's TLS for datagrams. So you have the API for doing that, for doing pre-shared key authentication, certificate-based authentication, all this kind of stuff. And when it comes to implementing a CoAP resource, it's basically just like an HTTP servlet. You provide the body for the GET method if you want to insert to a GET, possibly answer to the post, and if there are some parameters in your request, like MIME type, that kind of stuff, well, you have access to this in the API. So we're going to see in a demo later on how you can actually this is for the server, and so when you want to actually query the resource, there is a nice Firefox plugin we will use, which is quite useful for sort of debugging co-op scenarios. And then there's MQTT. I don't think I'm going to go into much detail because I'm pretty sure there's going to be more MQTT later on, or will there?
No, not in detail.
No, not even? Okay. Well, so very quickly, MQTT, the model is that you have a central broker, and if, say, you want from your smartphone to see the live temperature update from a kettle, then what it basically means is that both these guys are going to run MQTT clients. The smartphone is going to subscribe to a specific topic. I, Mr. Smartphone, I'm interested in everything under the topic hierarchy kettle232 / blah blah blah, could be anything. And then from that point, whenever another client publishes on a matching topic, in which case kettle232 / temp, then all the clients subscribed at the time will receive the notification. So that's a very simplified scenario. There are some nice additions in MQTT if you want to start doing to have different quality of services. When as a publisher you want to make sure that your message has been properly delivered, that kind of stuff. So that would be the kind of features that MQTT provide, but it's a very simple protocol. You can read the specification in maybe just an hour, and it's crystal clear. So at Eclipse, the client implementations, they are in the Eclipse Palo project. So there's Java, but there's more. JavaScript, like if you want to run Java's MQTT in the browser over WebSockets, that's something you can do. C, C++, you can run Palo and MQTT on an Arduino. And so for a Java developer, that would be the API. You can, oops, sorry about that. Okay. So the API for subscribing to a topic, well, basically you start it by setting the URI of the broker you want to connect to. You provide the callback that's going to be called whenever a message comes matching the subscription or subscriptions. You connect to the broker, and then you can start sending instructions to the broker. You can start subscribing to topics or publishing on topics. So in this case, I'm going to start receiving any message on the My Gateway topic hierarchy. So that's kind of the the client side, and then on the server side, on the broker side, there is Mosquito, which is a C implementation of a broker. So it's very scalable, it's very easy to run on even constrained devices. And then there is Moquette, if you're interested in running more Java implementation of a broker, then Moquette can run inside an OSGI container or as a standalone application. That's kind of the easy part, the connection, so I want to actually jump to the management and how you can start to actually go from a sort of prototype where you have your Raspberry Pi or your Arduino sitting next to you, and it's kind of easy to deploy an application because you're just basically tethered to your computer. If there is something that goes wrong, you just unplug and replug the device, it's going to reboot. That's kind of easy, but when you are actually starting to run an application on the field, you need remote management capabilities. You need the ability to set up the firewall maybe on your tens or hundreds of devices on the field. There is a fleet of devices running several applications. You want to know the version of the applications. You want to possibly update the applications, start an application, or rather stop an application that starts behaving badly. You want to deploy firmware upgrades, etc., etc. So at Eclipse, we have such an application container, if you will, for IoT. It's called Cura, and you can use Cura for developing your own IoT applications, as well as to take care of all the plumbing for your IoT gateway to run properly. You want Cura to take care of providing a nice abstraction for your applications to deal with accessing the sensors, maybe accessing a GPS if there is a GPS on your
device, you want an abstraction for that. You want your applications to all have a single and common way to communicate with the cloud. Like you don't want to deploy 3 applications that will all have to manage the life cycle of connecting to an MQTT broker, locally caching the data if the connection is down, and then flushing the data when the connection is back on. That's kind of the role of the gateway and of the application container. So that's what Cura is going to take care of for you. So it's very easy to install Cura on a Raspberry Pi, as well as on a BeagleBone or an Intel Edison, or of course on any other kind of gateway. And yeah, what is Cura doing? I guess this is where I should actually jump to the demo. So I have a Raspberry Pi over here, which is running Cura. There's a error, let's hide our web. I don't know. So let's jump to the Cura web UI. So this is a web browser. And I actually have access. As soon as you install Cura, you have a web UI that allows you to see basically the health of your device. What's the status of my gateway? Like, what is the MQTT broker my gateway is configured to talk to? This parameter is something that's going to be useful for all the applications that run on top of Cura, because they are all going to share the same broker connection. And yeah, as I explained earlier, what are the network settings? If I have a 3G dongle, maybe I'm going to use Cura to set up a TPT connection, and Cura is going to take care of always being connected to the network, and I won't have to develop my own shell scripts and whatnot. If I have a GPS, I could see the location from the web UI. So essentially what I see here is lots of nice ways in the UI to see what's happening on my gateway. What is the current version of Cura that I'm running? Cura being based on OSGI, what are the OSGI bundles currently deployed? Are they all properly activated, properly resolved? If I want to install a new bundle, well, maybe I can actually go in the package section and deploy a new application package. So what would that be? It's actually not bundles that you would deploy, that would be OSGI deployment packages. So in the OSGI specification, there is a standard way to aggregate different bundles in a so-called application. So that's basically a zip file containing a manifest and several bundles. That would be a deployment package. And in my scenario, I already deployed a greenhouse application, which we'll see in a minute. Back to the device section, you can do nice things like executing commands remotely. And what you need to keep in mind is that, yes, I'm doing this from my web browser, so you might think that it's not very different from like logging into the device. But the important thing here is that everything I can do from the web UI, I could also do it over RPC, right? Over by sending MQTT comments, I could perform such remote commands remotely. So if I want to massively reboot my 12 Raspberry Pis on the field, I could just send one command that would do it to all of them. Networking, I was mentioning cellular connectivity. If I want to set up a new PPP connection, or if I want to have to set up a DHCP server, that's something I could do from this section. I should also have access to the firewall rules. What are the ports I want to open for, possibly for the applications that are running on my device. And then, so that's kind of the administration of the gateway itself. But then, by using this UI, you can actually develop your own applications. Cura is exposing a set of APIs that you as an application developer can use for doing your stuff, which is monitoring a greenhouse, which is monitoring your car and stuff like that. So in my example, I actually deployed a greenhouse monitoring application, which is already running, which is exposing via some, I mean, the application is composed of several OSGI bundles. Those bundles might expose some services, and among which some of those services might actually be configurable. And if they are configurable, thanks to the OSGI meta type specification, well, the actual settings of the bundles and that the service is exposed can actually be typed, which allows Cura to provide you with a nice typed, if you will, user interface for actually setting the parameters of your application in a constrained way. Like this publish.quality of service parameter is an enum, and I've already defined beforehand what would be the accepted values for such a setting. And this could be a boolean, and this could be a freestyle string, etc., etc. So my application is actually already running, and it's leveraging the communication capabilities of Cura to talk and Qt. So once and for all, in my Cura environment, I've set up the broker I want all my applications to use, and then for my greenhouse application, the only thing missing is to indicate which topic I want my application to talk on, and that's basically it. So from this point, I actually have an app running, which is using those two sensors, well, rather this temperature sensor and this LED to sort of simulate a greenhouse. So I want to monitor the temperature of the greenhouse and possibly turn the light on or off. So all this over MQTT. In order to show you that it actually works, well, what I can do is use MQTT over WebSockets to pop up a web UI that I can that allows me to see right from my browser the current temperature. If I put my finger on the temperature sensor, and if I use the button to control the LED. So what's quite interesting with the web UI, so this is Pavo as well, right? It's only like 15 lines of JavaScript code for doing the stuff. If I go on the mobile, then I have the very same web UI, which has no backend whatsoever, right? It's full JavaScript, and I can do the same, right? Toggling the LED, seeing the temperature going up. Yeah. So that's quite cool. Well, maybe jumping, since I won't probably show all the slides, another way to visualize MQTT data is to use JavaFX and JavaFX charts. So using the MQTT Java client, so where would actually be my what the code is for my, yep. So how many lines? About 100 lines of code. Yeah, setting up a JavaFX chart. So basically, you need a bunch of axes, right? X-axis, which is going to be the time. How do I want to display the time on my X-axis? Well, I need sort of a label provider. Then on the Y-axis, I want to display the temperature. Blah, blah, blah. Define the series, the resolution for the chart. And then I need to set up an MQTT client. So setting up a connection to my Eclipse.org broker, right? And connecting to iot.eclipse.org, which is where we run an MQTT broker. And then the callback, whenever I receive a message, I want basically to add the message to the data series. At a given time, there is a given value. And that's it, subscribing to the topic where I know the temperature is going to start flowing, launching the chart. All right, so same, see how it goes. Right, let's of course I can still see the values on my phone, etc., etc. So you can very easily even one-to-one, one-to-many communication scenarios. And yeah, in Tahoe you have all the clients you can think of. All right. So maybe back to the slides. I think that would be it for Cura. Are there any questions on Cura? If you guys want to see actually how the code looks like for actually developing sort of the greenhouse demo, this is all on GitHub, and I would be happy to show you to send you the link afterwards if you'd like. Or in general, if you go to iot.eclipse.org/java/tutorial, there is a complete tutorial to show you how to implement the greenhouse demo. All right, so yeah, for visualizing and PG data, several options, JavaFX charts. If you want to run display, connect to an MQTT broker from your Android application, well, the Tahoe Java client is also plays well in an Android environment. You can run Tahoe as an Android service. So as if there are several applications talking to the same broker, this is all done through the same accessor, if you will. All right, so Eclipse IoT is not only Cura, and to some extent it's not only Java. For people interested in industrial IoT and SCADA kind of stuff, we have several IoT projects that implement IEC standards, for example, like for talking to industrial automation stuff. Rise V2G is actually quite interesting, a new project which implements, so V2G stands for vehicle to grid, so that's a standard for charging station. So there is an open source implementation of the charging station standard, so that kind of opens the door to interesting things if you want to start building applications for charging stations. Very quick demo about and around device management. There is a standard for doing device management which is called Lightweight M2M. It's a standard very similar to what you would find in your smartphone or in your cellular phone, and that the carriers use to update the software of the phone itself, like the radio stack. So Lightweight M2M is a similar standard, only it is targeted to M2M and IoT devices. And the idea is that on top of co-op, there is a standard way to do firmware upgrade and to monitor things like the battery level of a device. So at Eclipse, we have Wakama, which is the embedded stack that you would use to, if you're building your IoT thing using your own microcontroller and stuff, you would use Wakama to implement the device management stack, and Elation is the server side. So in just a few minutes, what does it mean? It means that if I want to manage a fleet of devices, I have somewhere, where is it over here? So Elation comes with a web UI. So this is basically the server that you would use to manage a fleet of devices at the hardware level. And when you start connecting a device, so in this case that would be an example device that runs on the command line, I start talking to my device management server, and what I start seeing, so this should actually be a real embedded device, right? And what M2M allows you to do is to have a standard view and a standard way to access the typical properties you would find and you would need to access to on an embedded device. Like you want to know what is the, you want to know the serial number of your device. You want to know what is the current battery level of the device. So, and maybe you actually want to observe the battery level because whenever the battery level is too low, you want to stop the device, or you want to stop an application that was being too aggressive on the battery usage. Maybe you want to observe how much bandwidth has your device consumed and stuff like that. You want to deploy a new firmware, you want to reboot the device, etc., etc. So that's, yeah, Wakanama is actually a very interesting project, and what's also very interesting is that you can run it on very constrained devices like an Arduino or an ARM embed. So that's, yeah, something you might want to have a look at. Then what do we have? Yeah, that would be device management. A few words about the newest, actually, Eclipse IoT project. It's called Kiyaki. It's being contributed by VeriSign, and I have a very, very, very short demo. But I really like this project because it actually leverages DNS for doing service discovery for IoT. The idea is that every IoT device basically has a unique identifier. One way or the other, there is, if we're talking about a device that is doing cellular, then there is the IMEI of the device, which is already the unique identifier. Or if there's, I mean, there's always a chip that allows you to have a unique identifier for your device, but you know when the device is leaving the factory, there is this unique identifier. So with DNS, what you can do is that the device, first time it starts, can actually start issuing DNS queries to start discovering configuration parameters. A device called xyz.acme.com can start querying the DNS server for the MQTT service, and then the DNS server will answer with the broker URI for this very specific device, which might not be the exact same parameters as for the ABC device, right? Maybe there is a general setting for all the devices in acme.com, but this can be overridden at the DNS level for a specific subdomain, if you will. And what's really interesting is that it can also leverage DNSSEC, DNS Secure, in order to make sure that whenever a device is receiving some settings over DNS, this cannot be tampered with, because the DNS records are basically signed using the public/private key pair that the device is holding. And whenever the device receives a DNS record, it knows for sure that it's his, or its, rather. A quick demo is using the Tayaki command line tool, and what I'm actually going to do is issue a DNS query for a device with a unique name. As I said earlier, every device will have its unique name, and I want to discover the MQTT parameters for my device. And I'm going to issue a query. And basically what it does is that it goes through, it queries the DNS server for the MQTT service, and then there might actually be several answers. The DNS server, depending on my physical location, might be able to provide me with some optimized settings. In this case, there's actually several brokers I can connect to, but they are ordered by preference or by priority, and in this case, it looks like the Austria MQTT broker is the one I should use in priority. So that's, yeah, that's basically the project that VeriSign is contributing. So they provide a Java client API, the C API is going to come too, and it's useful for discovering services as well as possibly for ciphering communication between devices. If you want to retrieve the public key for another device, you can actually query the DNS server for that. In the same way you would do if you do GPG or PGP communications, right? You need to know the public key of the person you want to talk to. So there are some key servers available. Well, with DNS, it's even easier. You just need to query the DNS server. I think the last demo is going to be smart home. You might know about OpenHub. It's this open source project for doing home automation. Eclipse Smart Home is kind of the infrastructure for OpenHub. It's the OSGI-based environment for having the rules engine, as well as the protocol implementations for doing home automation. If you want to do Zigbee, Philips Hue, if you want to talk to virtually any IoT device, there is an implementation of the so-called binding in Eclipse Smart Home. And well, the kind of stuff that you can do with Eclipse Smart Home is connecting a lead motion to a Philips Hue, and you basically set up a rule. So when you start rotating your finger, it's going to change the color on the color wheel. If you tap your finger, it's going to switch the smart bulb on or off. And what's really neat in Smart Home, I'm going to switch to a natural light demo now. So I'm going to launch my Smart Home instance. Where would that be? So starting the Smart Home / Open Hub demo environment. And what I'm going to end up with is a web UI. Hasn't started yet. And so, yeah, the Smart Home runtime, by default, it's basically just exposing a set of REST APIs for retrieving like the current value, current color of your Philips Hue, or for configuring a new object that you just bought. You just bought a smart thermostat. You want to use the REST API to sort of provision it. But then, of course, on top of the REST API, what's interesting is to have a web UI, or at least a UI, right? So historically, the UI looked like this, which is kind of nice on a smartphone, but especially on an iPhone, I guess. But now they have an even fancier UI. They call it Paper UI, which is yeah, way nicer. It's like on the desktop, it will look like this. Of course, if I go responsive and if I want to switch sort of to the mobile layout, it's going to look like this. And the kind of stuff that you find in Eclipse Smart Home and that wasn't available until now is that from the UI itself, you can actually discover new things or yeah, declare new objects and new things that you buy as you buy them. You don't have to tinker with the configuration settings of your smart home environment. So what this means, in this setup environment, I actually have several plugins installed to support a Philips Smart Hue, which I don't have, an internet, the internet printer protocol. I don't have any printer on this network, so I cannot really talk internet printers to printers. I talk to a Sonos. I don't have a Sonos either, but there is a Yahoo weather binding which is available. And now what can I do with this? Well, I can go to the setup wizard, and actually all those bindings I just listed, they might be able to do auto discovery. If I had a Philips Smart Hue on my network, it would be available, and I would just need to go to the setup wizard and to finalize the setup of my thing. So I don't have a Smart Hue, I don't have a Sonos, but I have the weather service that is able, according to my IP address, to localize me, to locate me, and the only thing I need to do is to confirm that I want indeed to add this thing to my setup. So this thing is going to provide me with some weather information. So in the UI, I want to add this thing to the weather tab, and then that's it. I can start going to the main web UI, switch to the weather tab, and there is a new contribution in there for the weather in Vienna. And if I want to configure and to tweak the UI some more, I can go to the configuration tab and start adding some groups and this and that. Of course, this is very simple setup. I want a new tab for the democamp, and it's going to show there. Of course, it's going to be empty. So yeah, that's it for Smart Home. I think I had there somewhere. if you go to the Open Hub website, you will see there is literally a ton of available bindings for asterisk zip server if you want to sort of call someone whenever something happens on a device, if you want to talk Bluetooth, if you want to talk again to a printer, if you want to talk to store your temperature history on your Dropbox, etc., etc. I think there was about 200 bindings available. So back to the slide, but I think I'm done with the slides. That was for smart home. If you were to remember only three things, of course, Cura is pretty cool, so go check it out, download it, install it on your Raspberry Pi. There is the tutorial I mentioned, and there's much more than just Cura, just Java, just smart home. If you want to make sure to check out all the projects, the best starting point is iot.eclipse.org. Please get in touch with the project from the mailing lists, etc. And maybe a few words about what's next, but I've covered already some of this stuff. There's more and more happening in the device management space, so like Red and RAM, of course, but there are discussions throughout like over Infinity, for example. Around security, there is TLAC, of course, the tiny TLS is also coming, so that's an implementation of TLS for C++. And some early discussions about providing open source stuff in the server. And that's it. Please send me any questions you may have. It's quite easy, Benjamin@eclipse.org, and ping me on Twitter. And again, iot.eclipse.org. And with this, I guess I'm way over time.